Okay, right. So we said the other day that we were going to have a look at hydrocarbons. There we go. Okay, so hydrocarbons. I mentioned the other day, and you should know this from, I think, you'll need to know this for ecology as well, that oil comes from decomposed animal tissue, mainly marine microorganisms, and coal comes from decomposed and compressed plant material. Okay, natural gas also comes from decomposed animal material. Okay, so that's the first thing. Now, I mentioned last time with hydrocarbons, there's quite a bit of information that needs to be covered. Okay, in terms of key learning intentions, but long story short, it all comes down to the name, hydrocarbon. These are compounds that consist of hydrogen and carbon. You have a carbon chain and you have hydrogens attached to that carbon. Okay, and a really key point here, let's see, infant variety. Okay, this one up here is not really explicitly explained, but look, when stuff comes out of an oil well, you get carbon chains of all sorts of different lengths. It's not a uniform thing, okay? It's not all of the oil that comes out of an oil well has carbon chains that are exactly 10 carbons long. Oh, wouldn't that be neat? No, they're all sorts of different lengths. The very short ones are the natural gases, the longer ones become liquids, and the really, really long ones are very viscous and ultimately get used for things like bitumen and for our roadways. Okay, so they come out in different ways. The foundation of hydrocarbons are carbon atoms. We know that carbon has 4 valence electrons. It shares 4 electrons to gain 4 electrons. We know this through our covalent bonding. So every carbon that you see in a hydrocarbon will share 4 electrons. There are no lone pairs in any of this, I tell a lie, and in any of the alkanes, alkenes and alkynes, but in alcohols there are, because alcohols contain oxygen, which will have its 2 lone pairs. So there's our Lewis diagram for methane, and here is our structural diagram for methane. Carbon sharing 4 electrons with 4 hydrogens, and each hydrogen sharing 1 electron with the carbon. Now, we're not too concerned about aromatic rings and things like that, the aliphatics and these ideas. We're looking at the aliphatics, the straight and branched chains of hydrocarbons. These aromatics, the rings up here, we just don't deal with in a meaningful sense. We just touch on it peripherally when we talk about pharmaceuticals. Okay? But hydrocarbons contain only carbon and hydrogen. Okay? All other organic compounds come from hydrocarbons. So things are attached to those hydrocarbons. This is a key slide. Here is a structural diagram. Oh, what is the name of this? Methane, ethane, propane, butane, pentane. It has 5 carbons. If you look on the diagram I've given you, on that first page, you'll see the prefixes. Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. Yes?
On the next page where it's ethane, the formula's wrong.
We'll sort that out later. Now, on that front page, those prefixes you need to memorise. You're not getting around that. If someone asks you to draw nonane, or nonene, or nonine, you need to know that that's 9 carbons. Okay? Or in a situation where it's non-3-ene, you need to know it's a double bond on the 3rd carbon and there are 9 carbons. But we'll get to that. Okay? Those prefixes you need to know. So I know that this is pentane because it has 5 carbons. And it's got its hydrogens. That's the structural diagram. The drawing, if you like. Okay? Now, the chemical formula, you just count them. There are 5 carbons and 12 hydrogens. That's it. That's all you need to know. The structural formula, you'll be doing a few of those. You just get rid of the lines, it saves space. CH3, so you just read it off. CH3, CH2, 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 CH3. Fair enough. But when when you get a lot of it, you'll notice CH2 is the repeating unit in hydrocarbons. They go out 60 long, and you'll have these two on the end, like bookends, and then 58 CH2s in the middle, and that's a lot of CH2s to write down or draw. So, just use parentheses and put 3 CH2s. You cannot do that with the ends, because they're not connected to each other. They make up the end of the molecule. And there is a ball and stick diagram. You should be able to interpret those, but you don't need to ever draw them. Okay? And that, in each case, is the same molecule. Now, this is the diagram I've given you, and the one we'll be working with today, and that is a lot of information. Okay? But there's a few things, I'll touch on them, but then I'll be coming back to them. So let's have a look at this idea of hydrocarbons. Now, if you have a long chain, if you have a short chain hydrocarbon, if you have 1 to 4 carbons, that's a short chain. That's just going to be a gas. Okay? It's going to be volatile, non-viscous, low boiling point, as you'd expect. 5 to 17 are liquid, and the longer the carbon chain gets, the thicker this oily substance becomes. Okay, it gets thicker and thicker and thicker. And then you get up to your 18 or more carbons, and they'll go out to 60s and 70s, and it just gets thicker and thicker and thicker as you go, and this is really becoming a solid. Okay, sort of a solid. Class it as a solid. Okay, if it's short, it's volatile, explosive, easy to combust, non-viscous, low boiling point. We talked about this before. If it's long, it's not volatile, so you can't light it very easily. A long chain hydrocarbon is the roadway outside, doesn't burst into flames very easily, and thankfully. So, viscous, high boiling point, and there's a key point here you don't have on your notes. The longer the chain, the higher the energy you get out of it when you burn it. Okay? The longer the carbon chain, the higher the energy you get out of it. That's why you don't see cars driving around with methane as their primary source of fuel. Okay, plenty of methane around, very easy to extract from cows. You just give them a poke and they'll burp, and that's methane. But it's not very energy dense. And we're going to talk about what it is about these chains. The longer the chain, the greater the energy. But that's a key point. The other extra point is down here. Now today we're interested in the alkanes, alkenes and alkynes, and later on the alcohols, which have an OH group on them. So this is the alkanes, alkenes, alkynes only have hydrogen and carbon. The alcohols have at least one OH somewhere in there. Okay? And all of the alkanes follow this general formula. We say they're saturated because every carbon has a single bond, and then it has the maximum number of hydrogens possible, and every carbon shares how many electrons? 4. Just get that in your head. All carbons share 4 electrons. Okay? And so that's an alkane. And we're going to practice this, so don't worry too much. The alkene, the formula is slightly different because somewhere in that alkene is a double bond between 2 carbons. There's a carbon-carbon double bond. And on the next slide that will become clear. So we say it's unsaturated because we don't have the maximum number of hydrogens. An alkyne, somewhere in that carbon chain, is a triple bond. You can have more than one, but we're nice to you. We generally only have one triple bond. And that's the formula that we use to calculate, where n is the number of carbons, and the number of hydrogens will be 2 times the number of carbons minus 2. If I have 10 carbons, I have 2 times 10 is 20, minus 2 is 18. So I'd expect the formula to be C10H18 of that particular hydrocarbon. What would be the name of C10H18? Yep.
Decine.
Decine. Dec, 10 carbons, and it's got a triple bond, so it has ine as the prefix. Decine. Okay, it's just patterns. This is what you start the name with, and one of these 3 is how you end the name, and that depends if there's a single carbon-carbon bond, a double carbon-carbon bond, or a triple carbon-carbon bond. Now, in terms of naming, The number preceding the ene or the yne name indicates the carbon atom on which the ene double bond or yne triple bond is found. So but1-ene, we'll see this on the next slide, but1-ene has a double bond on the first carbon. But2-ene has a double bond on the second carbon. You'll see this on the next slide. We'll go through exactly that. It will be quite clear. And when you draw structural diagrams, you have to show where the double or the triple bond is. And we'll do that on the next slide as well. Okay, we'll do a little practice. But these are the rules of our game. Oh, here's a structural diagram demo. 1, 2, 3 carbons. What is the name of this compound with 3 carbons? Who wants to volunteer? 3 carbon compound and with a double bond. Yep. Propene. Yes. Propene. It has a double bond and it has 3 carbons. Now, let's have a look here. Just this section. You've got this information, we've had a look at it. Let's look at our example. Here is butane. How do I know it's butane? 1, 2, 3, 4 carbons. But is the prefix. And ane, an alkane, only has single bonds between the carbons. There, there, there. Single bonds between each of the carbons. So it is butane. Now here is another 4 carbon chain. 1, 2, 3, 4. So it's but, but there is a double bond. Butene. And it can be butene or it can be but1-ene. We'd accept either of those, but it's got a double bond on the first carbons, so it's but1-ene. Okay? Simple enough, I hope. And is that a valid structural diagram? How many electrons do all carbons share? 4. So let's count them. That carbon is sharing 1, 2, 3, 4. This carbon is sharing 1, 2, 3, 4. Carbon 1, 2, 3, 4. Carbon 1, 2, 3, 4. And each hydrogen only shares 1. A valid structural diagram. Now, here we have but1-ine. The ine meaning there's a triple bond on the first carbon of a 4 carbon chain. Here's our 4 carbon chain. There is the triple bond. Is this a valid structural diagram? Count them. 1 shared electron, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. That is a valid structural diagram. It has a triple bond on the first carbon. Here's but2-ine. It's a triple bond on the second carbon. 1, 2, 3, 4. Here's the second carbon. 1, 2. There's the triple bond. Can I have but3-ine?
Yes, you can.
Everyone wants to say yes. Fantastic. No. Okay. Because if you're saying, hey, Mr. Maz, why don't you just put a triple bond on this third carbon here? Yes. Right. Put the triple. But if I grab that and turn it around, it's the same as that one. So no, you cannot. Those are the only 2 isomers of butane. There's only the 2 that can exist. Yes?
But doesn't it only have 1
Triple bond?
On the second
Yes?
carbon.
It's on the second carbon. This is carbon 1 has a triple bond. This is the 1, 2. Second carbon has a triple bond.
Is that what that one means?
Yes.
Number okay.
First location.
Oh, okay,
Second
that makes
location.
sense.
Yes.
When you get into like the pent
Yeah.
and that, can you do it for like the first 3 and first 4 but not
Yeah.
the last?
Now, very good. Miller's picked up on a point. I can only, with butene or butine, only have 2 possibilities for double and triple bonds in terms of carbons. But the longer they get, the more possibilities there are. Until it gets crazy, absolutely insane. And like you can do things like, it gets kind of exciting because you can do deck 1, 2, 3, 4, 5 ene, meaning there are 5 double bonds between carbon 1, carbon 2, carbon 3. Like it's really kind of nutsy, but we don't do that to you. It's too complex. But the point that you've made is a good one, that the longer these chains get, the more variation you can have. And we'll talk about that. Does anyone have any questions about this naming convention with the number, or the naming convention with the prefix and the suffix being ain, een, or ein? Ain means single bonds only. Een means, and guess what? They're even alphabetic, so don't complain. A, first letter of the alphabet. Only one single bonds between the carbons. E is the second in terms of alphabeticity, the second letter you can get to. And there's your double bond. Ein, right down the end, there's a triple bond. And oh my goodness, look, Y is made up of 3 lines as well, just to really help you out. Okay, any other questions? Okay, I had a question for you. Oh yeah, structural diagrams. Draw the structural diagram of those first 3. Yes.
Don't you mean the
Structural diagram.
3D? Isn't that the Lewis dot?
No, I said this. Sorry, you're right. I'm wrong. That is a structural diagram. See, okay. The structural formula of these 3. Well done, Jasper. Okay. Structural formula of those 3. I'll give you a minute. It should take very little time because you're just going CH3, CH2, CH2, hopefully.
You want the full one?
I want the structural formula. Not the condensed structural formula. The structural formula. Don't forget this rule. For the structural formula, you need to show where the double bond is or the triple bond is. This is a structural formula, not a structural, condensed structural formula. Hopefully butane's easy. Something like that.
Oh yeah.
CH3, look, hey, let's look at structural formulas. Read them off. CH3, CH2, CH2, CH3, yes.
For the but
Yes?
how would you write H minus? Oh, it's just that.
It's just there. That's why I put it there, but that's why we're working on this, so you know to look there. Okay? You'd go CH, how many H's? 2, CH2, oh, CH, CH2, CH3. There is my structural formula for butene. Notice the location of the double bond. I'm just taking every other line out except the bond location. Butene, read it off. CH, dot, 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 C, CH2, CH3. And that would be, I mean, if you can remember, hydrocarbons is a big branch of chemistry, but if you can remember these basic rules, then in terms of names and things like that, it is logically designed. In the old days, every time they found something different, they just gave it a unique name. But there's an infinite number of these compounds, and not an infinite number of words, and so that's not a very logical way of doing things. And you're calling it isopropanol over here, and someone else is calling it something else over there. It doesn't work. But this convention does. It actually, so don't try to remember everything, just look at the patterns, okay? Has everyone got those down? Can I change slides?
We didn't need to write the structural diagram.
Sorry?
You don't need the diagram as well.
No, that is the structural diagram.
Yeah.
Oh, actually, on your sheets, I would copy the structural diagrams for those. Yeah, on your front sheet, I would do those structural diagrams, just copy them. And then, ladies and gentlemen, I will get you to complete the first 10 of each.